Welcome pre-cal students to class today on this Tuesday the 18th. Hope you guys are doing well and hope you're ready to learn some math today. Let's go over some quick announcements here. There will be a test this coming Monday, so if you're not going to make it over to my house, please make sure you let me know. Matthew and Caleb no later than Monday. Your quizzes are due by tomorrow, Wednesday. All questions asked, everything turned in. So all quizzes due by Wednesday. Please stay on top of your integrity sheets. Remember, they're called integrity because I expect you guys to be honest. And so make sure that you are taking care of all of your integrity sheets and doing your homework. Feel free to call or email anytime that you have questions. All right? Okay, let's jump right into this. Let's start off with a really quick review of yesterday's math, really quick. First of all, what we learned yesterday is when you're graphing a quadratic equation, you find the vertex by negative b over 2a, and once you get that number, in this case it would be negative 14 over 2, negative 7, you then put negative 7 back into the equation, and you'll get a number out over here. And then of course, going up, we'd have a negative 6, a negative 5, going down a negative 8 and a negative 9. And then don't forget you get out a parabola like this, and this middle point here is called the vertex, and this imaginary line that goes right through the middle is called your axis of symmetry. And sometimes the parabolas will open downward. In fact, in this example here, because your x squared term is negative right here, the parabola will open downward. Okay, just a quick review of what we learned yesterday. And then don't forget this form here. It's called Vertex Form. Whenever an equation is written in this form here, you know the vertex right away. You always change the sign of this number, and you do not change the sign of this number here. All right? And of course, from then you put the 4, 3 here and put your numbers and go ahead and graph the parabola. Okay? So I hope that's a help to you. Just a little quick review. All right. There will not be any homework given in class today. The video is pretty long, so that is the reason I'm not giving homework. Also, another reason is because the homework assignment that I'm going to give you tomorrow is really long. And I try to be really balanced in how much work I give you every day. I was the same way when I was a classroom teacher. I want to be I want to be tough on you guys, but I also want to be reasonable. And so tomorrow you will have a quick 1 to 2 minute video to watch where I make announcements and remind you of things, and give you the assignment, and then I will give you a pretty long homework assignment. So there'll be no. So if you've noticed the video is long today, there's no homework after class today. Okay. We are going to solve some pretty cool equations today. I think it's stuff that you guys have probably never seen, at least some of it is, and so you'll enjoy learning something new. It's very important to be able to tell the difference between the different equations because each one is solved differently. So if you cannot look at the equation and say, oh, that's an absolute value equation, or that's a square root equation, etc., and then it's not going to be easy for you. So let me very quickly put up 3 examples of the types of equations we'll be solving today, okay? Go ahead and copy these down. These go together here when I say 3 examples, okay? Now, these 2 equations here, you take whatever notes you want to, okay? These are called rational equations. Now, we're going to stick to what the book says. I do disagree a little bit with this because, to be honest with you, if you'll watch this equation right here for a second, I could actually simply split this up into x over 3 and then take your minus sign here, minus 8/3 plus x over 2 minus 3/2 equals 0, and then x over 3 is just 1/3 x minus 8/3 plus 1/2 x minus 3/2, and now I have a good old algebra 1 linear equation. All of you guys could solve this, okay? So, you know, I'm not going to split hairs with them. My definition of a rational equation personally would be one like this one here, where there's x's or unknowns in the denominator. But either way, that's fine. The main thing you need to see is this. Rational equations are equations like this that have these fractions in them, okay? We call them rational equations. And I'm going to give you steps later on how to solve those, okay? Obviously, this equation here is called an absolute value equation. An absolute value equation, because you have an absolute value with an x inside. And I will give you steps later on how to solve this type of equation. And then over here we would call this a root equation. Now a lot of people would call it a square root equation, which is fine. The reason I'm not doing that is in your homework you're not only going to have square roots, you're going to have cubed roots and other indexes right here. This is called an index, okay? Squared root, cubed root, etc. So these are called root equations, and I'm going to give you steps later on how to solve those. So once again, do you see the difference? I think it's really easy, but I want to make sure you can. These are called rational equations because we have rational expressions or fractions. These equations are called absolute value equations because you have an unknown inside the absolute value. And this equation here is called a root equation because it has an x inside of a square root. Okay? So these are the problems we're going to deal with today. So I think we're going to do about probably, I'm not sure, maybe 10 examples. I know we have 3 or 4 of this type and maybe 2 or 3 of this type and 3 here, something like that. So let's jump right into it. Please take some really good notes, and I think you'll understand this math, okay? Solving rational equations, the lesson number is 2.5. Please copy that into your notes, and the date today is the 18th. The date today is the 18th. Okay, 3/18/14, solving rational equations, lesson 2.5. Let's start off with some steps for solving rational equations. As always, I go fast. I expect you to just pause the video when you need to. And I've kind of crammed these in here. Usually I like to space them out, but I won't do that this time. Number 1, you want to factor any denominators that can be factored. Always do that first. Number 2, you then eliminate the fractions. Eliminate the fractions, and I will show you how to do all of this later. Number 3, you solve the remaining equation, and then look at number 4. This is something you're probably not used to doing. Check for any extraneous solutions, and I'll explain later why that happens and what you need to do there. Okay, so very quickly, factor any denominators, eliminate fractions, solve the remaining equation, check for any extraneous solutions. Okay, let's continue on. Let's start off with solving this equation right here. Okay, we'll pull this one down and we'll get this one up here out of the way. Alright, here we go. Let's solve this equation. Please take some really good notes. Now, notice we have a rational equation, and step 1 says factor any denominators that can be factored. Well, you cannot factor a 3 and you cannot factor a 2. So step 1 is done. No factoring can take place. Step 2 says eliminate fractions. Now here's how you do that. You look at all of your denominators and you find a common denominator. Okay? A common denominator. Well, a common denominator for 3 and 2 would be 6. So what I do is I multiply the entire equation by 6/1. 6/1 is just 6, and I think it's a lot easier to put 6/1 so you can see what's happening here. For example, 6/1 times x over x minus 8 over 3. Well, notice your 3 would cancel with your 6, and then when you multiply your 2 through right here, you would have 2 times x is 2x, and 2 times negative 8 is negative 16. There. Notice how that fraction is totally gone now. Now I'm going to multiply 6/1 times x minus 3 over 2. Your 2 would cancel with your 6 3 times, and then take your 3 and multiply it times this expression right here. And don't forget there's a positive sign here, so it'd be 3 times x would be a positive 3x. And then 3 times negative 3 is a negative 9. Equals 0. Look at that. Now that equation became so much easier. And now we solve. And that's what step 3 says to do. Step 3 says solve the remaining equation and check for any extraneous solutions. Okay, here we go. Well, if I combine my x's, I get 5x. If I combine my constant terms, I get a negative 25. Bring your 25 over and make it positive. You're left with 5x equals 25. And then divide both sides by 5. And x equals 5. Now, Extraneous solutions, of course, means solutions sometimes that you get out in a problem, but they're extra solutions. They're not really true solutions, okay? And so you have to check those sometimes in rational expressions. Now, I'll explain why a little later, but for right now, if you put a 5 in here for x, and if you put a 5 in for x, you're totally fine. 5 minus 8 is negative 3. Negative 3 over 3 is negative 1. 5 minus 3 is 2. 2 over 2 is 1. So you have negative 1 plus 1 equals 0. And that's totally a true statement. All right? And so the answer to the first equation would be 5. All right? Not too difficult. Just getting rid of your fractions and going from there. Okay? All right, here we go. Let's take a look at this next problem. All right, now let's take a look at this equation here. First of all, we notice it's a rational expression, so we know the first thing that we're going to do is we're going to factor any denominators that can be factored. Well, you can't factor x minus 3, x minus 3. There's nothing you can do. There's nothing common you can pull out, and we do not know the square root of this term or this term, so there's really nothing we can do there, okay? All right, so we're not going to factor anything. Step 2 says eliminate your fractions. Now, a common denominator for x minus 3 and x minus 3 would simply be x minus 3. I mean, your denominators are already the same, so I'm going to multiply this equation by x minus 3 over 1. Now, here we go. X minus 3 over 1 times this fraction here, your x minus 3 would cancel with your x minus 3, and it would just leave you with x squared over 1, which is just x squared. And then when you take this fraction here times this fraction here, your x minus 3 cancels with your x minus 3, and you're just left with 9. Wow, that's pretty simple. Now we take the square root of both sides. The square root of x squared would be x, and the square root of 9 would be, don't forget your positive negative, your square root of 9 would be plus minus 3, or positive negative 3. Okay? Now, we think those are our solutions, but they're not, and let me show you why. Okay? Remember, the last step is to check for extraneous solutions. Well, a negative 3 is just fine. If you put a negative 3 in here and square a negative 3, you get a positive 9. Okay? And then 3, did I say a negative 3? And a negative 3 minus 3 would be 6, and a negative 3 minus 3 would be a negative 6 would be a negative 6. So you get 9 over negative 6 equals 9 over negative 6. Okay, I kind of went fast there, probably didn't do a very good job, but trust me, negative 3 works just fine. But positive 3 does not, because when you put a positive 3 in right here and here, 3 minus 3 is 0, and you get a 0 in the denominator, and you can never have 0 in the denominator. So there's no way 3 can be part of your solution. It can't be, because it gives you out an impossible answer. So the answer is x minus negative 3. Now, I told you I would explain why this happens. Watch carefully. Let me get a drink here. Anytime you multiply an equation by a variable, that means a letter, an unknown, which we did. Look at what we multiplied this equation by. X minus 3, right? And wasn't there a variable right here? Sure there was. Anytime you multiply an equation by a variable, sometimes you will get out extra answers, or in other words, extra x answers, which to me totally makes sense, because when you multiplied everything by x, you're getting some extra x's in here. It's not a number. And so sometimes you will get extraneous or extra solutions. Now notice in the last problem that we did, and I don't have that problem in front of me, I think it was, here it is, I see it now, x minus 8 over 3 plus x minus 3 over 2. Remember the first problem we did? Well, we multiplied everything by what number? 6. Look back in your notes and you'll see. Were there any x's here that we multiplied by? No, there wasn't. So you really didn't need to check your answer. Now I did it to set a good example, but if you didn't multiply the equation by x or by an unknown, then there's no need to check your answer. You will not have any extra solutions. And by the way, sometimes you won't have any extra solutions. Sometimes you'll multiply an equation by an unknown and you still won't have any extra solutions. That happens sometimes, okay? All right, let's continue on. Here we go. Please pay attention. Let's go ahead and solve this equation here. Step 1 says to factor any denominators that can be factored. Well, none of these denominators can be factored at all. So now we're going to find a common denominator for 1t, 2t, and 3t. Well, let's start with the whole numbers first. 1, 2, and 3. A common denominator for 1, 2, and 3 would be 6. Now, look at your t's. I have 1t here because the power is a 1. I have 1t here because the power is a 1. And I have 1t here. So which group has the most t's? Well, they all have 1. So I only need 1t for my common denominator. We've done this before when we were adding and subtracting rational expressions. We've done this, okay? So a common denominator, that's a little big, isn't it? A common denominator for these three denominators would be 6t. If you need to back the video up and watch that again, feel free to do that. Okay, there we go. Now, let's see what happens. 6t over 1 times 1 over t. Your t would cancel with your t, and you're left with 6 times 1, which of course is just 6. Now, we're going to take 6t over 1 times 1 over 2t. Your 2 would cancel with your 6 3 times, and your t would cancel with your t. So you're left with 3 times 1, and obviously 3 times 1 is going to be 3. And then my 3t, well, let's see, 3 would go into 6 2 times, and my t's would totally cancel. So 3t cancels into 6t 2 times. 2 times 1 is 2. Okay, now here's where a lot of students make a mistake. They forget to also multiply the fraction by everything, which means the right side over here too. And so 6t over 1 times 5 is going to give you, I'll be careful on this, if you need to put the 5 over 1, feel free to. 6t times 5 would give you 30t over 1, or just 30t. And now we have really a simple equation to solve. We're left with 11 equals 30t. Divide both sides by 30, and your answer is 11 30ths. Now you say, Mr. Earhart, that's a really difficult answer to check. You're right, but with graphing calculators, guys, I mean, seriously, it's not, or with any, even with scientific calculator, it's not that hard. I mean, if you typed into your calculator 1 divided by 11 30ths, you'll get 30 over 11. And then if you take 2 times 11 30ths and then flip, and then take 1 divided by that number, you will get 30 over 22. And then over here, if you take 3 times t, 3 times 11 over 30, and then take 1 divided by that number, you'll get 30 over 33. And then with your graphing calculator, if you type all these fractions in, you will see this would become a 90, let's see. No, I do stand corrected. Sorry, I was thinking that I could find a common denominator pretty quickly, but 22 would not go into 33. But anyways, if you take your graphing calculator and type in these three fractions and add them, you will get 5 equals 5. Okay, 5 equals 5. And so be sure and always check your answer like you're supposed to do, because you did multiply by 6t, which means you multiplied by a variable right here, t. Okay. Now I warned you guys, this equation, this video is going to be long. Okay, guys, but tough it out, and there'll be no homework when you're done watching it. You're done watching it. Okay, last equation. Here we go. All right. Step 1 says, let me get a drink here. All right, step 1 says factor any denominators that can be factored. Well, you cannot factor this denominator, and you cannot factor this denominator. However, you can factor this denominator. You can pull a y out. So I'm going to pull out a y, and I'm left with y plus 5. Okay? There we go. Now step 2 says eliminate your fractions. Okay? So I'm thinking to myself, okay, I've got to find a common denominator for all of this. Remember how to do that, students? You compare one-termers with one-termers, two-termers with two-termers. For example, I have a one-termer here, I have no one-termers here, and I have a one-term here. Compare your y with your y. How many y's do you have in this group? 1. How many y's in this group? 1. Let me stop right there. Some of you are seeing, Caleb or Matthew, you're seeing this y here and saying, I've got 2 y's. Now you're only comparing monomials with monomials. Okay, that's one-termers, okay? So this is a monomial and this is a monomial. How many y's here? 1. How many y's here? 1. So how many y's do I have at the most in one group? Well, they both have 1, so I'm just going to use 1 y. Now let's say this had been squared. Then I would say, okay, there's 1 y here, there's 2 y's here. Which group has the most? This group does, so I'm going to use 2 y's, y squared. Okay, that's how you would do that if there was a y squared. Now look at your binomials. Here's a binomial here, and here's a binomial here, and there's no binomials over here. So we compare binomials with binomials, okay? How many groups of y plus 5 do I have? Well, there's like a power of 1 here. And how many groups of y plus 5 do I have here? 1. Now if this was a 2, then you would come over here and you would put y plus 5 to the second power, okay? But that's not the case. In both of my denominators, I have a power of 1 here and a power of 1 here. So I have one group of y plus 5 and one group of y plus 5. So if I have one group of y plus 5, then I come over here and I put this. So there is my common denominator. There it is. Okay? So not too bad, guys. Really not too bad at all. Let's see if we can't shrink this down a little bit and bring it on over here. So we found the common denominator. And now remember what I'm going to do. Step 2 says to eliminate my fractions. So I'm going to multiply my entire equation by y parentheses y plus 5. So this fraction times this fraction, notice this denominator would cancel with this. So there's really just a 1 here. So 1 times 3y minus 5 would give you 3y minus 5. And now this fraction right here is totally gone. Okay, now we're going to multiply this fraction here times this fraction here. Notice your y plus 5 would cancel with your y plus 5, and you're left with just a y. So you take y times this whole expression right here, okay? And when you do that correctly, you would have y times y would be y squared, and y times 4 would be 4y. Then bring down your equal sign, and now let's go ahead and do this one more time. Okay, we have this fraction right here, and we're going to multiply it times this fraction right here. So notice when you do that, your y here would cancel with your y, leaving you with y plus 5. So now be careful here. It's a binomial times a binomial. Y plus 5 times y plus 1. Now you should know by now how to do that. So I'm going to very quickly do that for you. You'll simply get y squared plus 6y plus 5. Trust me, that's correct. And now let's continue on and finish the problem, okay? Now the first thing I noticed, and I hope you guys are learning to see stuff like this, okay? The first thing I notice is that I have a quadratic equation. Guys, you should have seen that right away, just to be honest with you. You should see right away that you have a y squared, okay? And you should see right away that's your highest power. Anytime you have a square root, a quadratic equation or a cubic or quartic, a third degree, fourth degree, you need to first of all get one side equal to what? 0. So that way in this problem here, we can either factor or use the quadratic formula. But look what happens once you get one side equal to 0. Watch. When you bring your y squared over, it cancels with your y squared. So this term is gone. Okay? Now, bring your 6y over, and when you bring your 6y over, it becomes a negative 6y, correct? So I have a 3y, a negative 6y, and a positive 4y. When you combine all of those terms, you end up getting a positive 1y, or we can just say a positive y. Now, see this negative 5, right, or this positive 5, when you bring it over and it becomes a negative 5, you're then left with a negative 10. Now, if you need to back the video up and watch all of this again, feel free to. Okay, I have no problem with that. And boy, you know what I made a mistake on? I apologize. I should have never, boy, I really messed up, guys. I should have never gotten rid of that equation because we have to check our answer, but that's okay. Too late now. So anyways, now do you see it? Let me review again what I did. As soon as I saw that I had a y squared, it was a quadratic equation, right away I wanted to get one side equal to 0 so I could factor or use the quadratic formula. But after I got one side equal to 0, the y squares cancel out, so I'm pretty happy about that. Now I just have a regular linear equation, so bring the negative 10 over and your answer is 10. Now again, I should not have eliminated that problem, and let's go back here. I think we have it on another page over here somewhere. No, we do not. Okay, well that's fine. The equation that we just solved, if you will give me a second here to try to find that, is right here, and I do apologize for getting rid of that. It's my fault. If you'll look in your notes, it should be this right here. I think I have found the correct one. And of course I'm writing very quickly, so excuse the sloppiness. Checking this quickly, making sure it's right. And looks like it is. Okay, now it looks like 10 works. Everywhere you put a 10 in here, you will get out a denominator that is not 0, and so 10 should work. Okay, so everything looks good there. Again, let's review. When you're solving these equations, factor any denominator that can be factored, eliminate fractions, solve the remaining equation, and then check for any extraneous solutions. In these problems here, you're checking to see if any of your denominators end up equaling 0. Okay, and in this case they will not. All right, let's continue on. Let's look at the next type of equation. Solving nth roots, and I do know how to spell, probably just a little quick typing there, error. Solving nth root equations, lesson 2.5. The date today is the 18th, of course, obviously, and let's continue on. Now, the reason I call these nth root equations is they're not all square root equations. Okay, some of the ones in your homework will be a cubed root or a fourth root. Okay, so solving nth root equations, lesson 2.5, and the lesson number or the date today is the 18th. All right, let's look at some steps real quick. You need to know these steps. All right, so please copy these steps down and do them very meticulously. When you are solving root equations, you first of all want to eliminate all radicals. Now this might take more than one step sometimes, and I'll explain that later. Step 2, solve the remaining equation. And then look at this once again, check for extraneous solutions. Look students, anytime you multiply an equation, once again, by a variable, which you'll see in a second we're going to do, you've got to check for extraneous solutions. Okay, that's very, very important. All right, so we must check for extraneous solutions. All right, okay, moving on. Here we go. Let's take a look at these problems, take some really good notes, and let's use these 3 steps. All right, here we go. We're going to do 2 problems, it looks like, and then we'll get into the other type of equation. All right, let's start off with this equation right here. Now, first of all, we want to eliminate all radicals. Sometimes this will take more than one step. Now, just like in the last equation, when I said eliminate fractions, I had to teach you how to do that. Well, I need to teach you how to eliminate a square root. So the first thing you want to do, you do not want to eliminate a square root until you get it by itself. So this is a positive 5. I'm going to bring the positive 5 over and make it a negative 5. So now I'm left with the square root of x plus 7 equals x minus 5. That's pretty simple, isn't it? Hopefully you understand what I've done there. I got the radical by itself. Now, if this 5 would have been right next to the radical and they were multiplying, then I would divide both sides by 5 to get rid of the 5. But the 5 is not multiplying times the radical, so we're good. Also, I want to show you something else you need to see. If this original problem would have had a negative sign in front of the radical, then you'd have to bring that negative sign down, and then you know what your next step would be? Your next step would be is to make this radical positive, but then you would come over here and you would change all of these signs, and your x would be negative and your 5 would be positive, okay? So when I say to get the radical all by itself, you really need to make sure you do that well and make sure it's completely by itself. You would not want a negative sign right here, okay? All right, so moving on. We're going to eliminate the radical. My voice is a little raspy. Hold on one second. Okay, I'm back. Sorry about that. Okay, now we're going to eliminate this radical. Now notice it is a square root. So because it's a square root, you're going to raise this to a second power. And notice, men, that you're raising the entire side to a second power. Please don't come over here and raise each term to the second power. That is incorrect. You are raising each side to a second power. That's why it was so important you got this radical all by itself. Now, when you square a square root, you're left with what's on the inside. And when you square x minus 5, that's the same thing as x minus 5 times x minus 5. So you would get x squared minus 10x plus 25. Look at that. And now you're ready to go ahead and solve. I notice right away I have a quadratic equation, so I'm going to get one side equal to 0. So I'm going to bring this x over and make it a negative x, put it right here. And I'm going to bring this 7 over and make it a negative 7 and put it right there. So I'm left with x squared minus 11x, and then let's see, what do we have here? Plus 18. All right. Now, thankfully, I hope I'm right, thankfully that can be factored, because if it couldn't be, it would really be a mess to use the quadratic formula and check my answer. But we would have to do it, and that would be a fair question, okay, on a test or a quiz. So let's take this and let's solve it. Now, like I said, I think we can factor the right side. Notice we have a trinomial with a lead coefficient of 1. And notice this power here is twice as big as this power here. We went over all of this last week, and now you see how your math builds, and you need to be caught up on your math, okay? So what two numbers multiplied together give me a positive 18, yet when added together give me a negative 11? Well, I think of these two numbers right away. If I multiply these, I get 18. If I combine them, I get a negative 11. So my factorization would be x minus 2, x minus 9. And now if you set each group equal to 0, you will get 2, 9. So we think those are our two answers. And in a second, we're going to find out. We're going to check them and see if we have extraneous solutions. So here we go. Let's put a 2 in here real quick. And we'll put a 2 over here. 2 plus 7 is 9. The square root of 9 is 3. And 5 plus 3 is 8. 8 does not equal 2. Let's go over that again. Let's put a 2 in for x. 2 plus 7 is 9. The square root of 9 is 3. 5 plus 3 is 8. 8 plus 3 does not, or 5 plus 3 is 8. 8 does not equal 2. Okay, so we know 2 is not one of your answers. Now let's put 9 in for x. So here is a 9, and here's a 9. 9 plus 7 is 16. The square root of 16 is 4, so 5 plus 4 equals 9. And that checks. 9 equals 9. So yes, your answer is 9. I hope that makes sense, guys. It's about it's just about ready to get a lot harder in this problem over here. So I hope you're getting this okay. All right. You first, maybe I should have called step 1 isolate the radical, and then step 2 eliminate. But either way, you want to get rid of your your radical, and you don't want to do that until you've isolated the radical, and then of course increase both sides to the second power. Now, before I get to this last problem in this section, I want to show you one thing you really need to see. Let's pretend this would have been a 3 right here. You still get the radical all by itself. And then because you have a 3 here, you have to raise this side to the third power, and you have to raise this side to the third power. And yes, this is going to be a pain. That would be x minus 5 times x minus 5 times x minus 5. But that's what you would have to do. So if you have a 3 here, then you raise it to the third power. Okay? And there's going to be some homework problems. I want to warn you right now, in tomorrow's homework, there's going to be some homework that you're going to struggle with, and I've done that on purpose. You need to do the homework, and you need to make sure that you're doing it very well, and looking for making sure you're understanding it, because I'm going to give you some pretty tough problems, okay? All right. Let me get a drink here, excuse me. And let's continue on. Now, let's go ahead and solve this square root equation. Notice, first of all, I have 2 I need to get rid of. Now, would you please listen to me carefully, students? It does not matter which one of these radicals you isolate first and then eliminate. It doesn't matter. That's totally your decision, okay? That's totally your decision. I'm just going to do this myself. I'm going to go ahead and put x minus 3 right here, the square root, and I'm going to bring this whole expression here to the other side. That's how I'm going to do it. So I'm going to have 4 minus, notice how there's a positive sign right here I'm circling, and when you bring it over it becomes negative. Okay. Now, because I have a square root, I'm going to raise both sides to the second power. Now, whenever you square a square root, you get what's just on the inside. Okay? Now, I want to show you a little shortcut here that will help you. Okay, so please watch carefully. This shortcut is really helpful. We learned this in Algebra 2. And forget this problem down here for just a second, if you would, please. I want to show you the shortcut on an easy problem. I'm going to make this an 8 so you're not confusing it with this down here. This is a totally unrelated problem. There's a shortcut you can use on these. You can square the x, square the negative 8, and then what I taught you guys to do is you multiply these two together in your head, which would be a negative 8x, and then multiply it by 2, which would be negative 16x, because 8x times 2 would be negative 16x. So that's a shortcut that's really going to be helpful on a problem like this. This is really going to be hard if you try to expand it and do it the long way. It'll work, but it's a lot more work. So let me go over this shortcut one more time in case you 2 young men have forgotten that from Algebra 2. You square this term. And this shortcut only works when you have a binomial and a power of 2 right here, okay? And then you square this term, and then you multiply these together, x times negative 8, and then you double it or multiply it by 2. And that works, and that's a shortcut, okay? And that's going to be really helpful now. So we come down here, we square our first term, and we square our second term. Now remember, whenever you square a square root, you get just what's on the inside, so we would have x plus 5. Okay? Now, we multiply these together, so 4 times the negative root would be negative 4 x plus 5. Do you see how I got that? Let's go over that again. I took this times this, so I have a positive 4 times the negative square root of x plus 5. A positive times a negative is a negative, and you simply write these side by side. Now when I say double this, you would then get this. Negative 8 square root of x plus 5. Don't forget your plus sign here. Okay? So when you double it, you're really multiplying the outside, not the inside. Okay? Back this up and watch it again if you need to. That's a really, really helpful shortcut that I really think you need to learn. Okay? Now, if you'll look at number 1 right here, let's get some room so we can work. Notice step 1 said this might take more than one step, okay? You understand that. Well, notice we have another radical to get rid of again, okay? So here's what we're going to do. We're going to get the radical all by itself again so we can get rid of this radical. So did we get rid of this radical over here? You bet we did. It's gone. That's a good job. But now we've got another radical here that we need to get rid of. So we're going to get that radical all by itself. So we're going to have to bring the 16 over and make it a negative 16. We're going to have to bring the x over and make it a negative x. We're going to have to bring the 5 over and make it a negative 5. So now I'm left with negative 8 square root of x plus 5. Now, obviously your x's cancel, that's fine. And then when you combine these, I believe you get negative 24. Okay, so I'm going to squeeze in right here a negative 24. Okay, do you see what I've done there? I moved all of these terms over so I can get the radical by itself. Now, is the radical by itself yet? No way, not at all. There's a negative 8 here. So now I've got to divide by negative 8, divide by negative 8. And if I do that correctly, a negative 24 divided by negative 8 is 3. Over here, your negative 8's cancel, and you're left with the square root of x plus 5. Now we're finally getting somewhere. Okay, now we have the square root we want to get rid of, so we're going to raise it to the second power. We raise this side to the second power, and you get 9 equals x plus 5. Okay, square the 3, you get a 9. Square a square root, you get the radicand. Now bring the 5 over and make it a negative 5, and 4 equals x. Okay, so let's see what happens. Let's see if our answer actually works. Maybe it will, maybe it won't. And by the way, now you see why I'm not giving you homework tonight. There's a lot of homework I'm going to give you because you need to practice these. And no different than soccer, guys, you've got to practice these so that you really understand them, okay? Well, let's check our answer. We're going to put a 4 right here, and we're going to put a 4 right here. 4 minus 3 is 1, and the square root of 1 is 1, plus 4 plus 5 is 9, and the square root of 9 is 3. So 1 plus 3 equals 4. 4 equals 4. Okay? So there we go. This answer did work. What if it had not worked? Then the answer would be no solution. That means none of the answers worked that you got out, and so there's no solution. Okay? All right, let's continue on to one more type of equation. And again, for the 10th time, I know the video's long, but there's no homework today. Okay? So we're almost done. Solving absolute value equations. Solving absolute value equations. Here we go. Please copy these steps down. Step 1, isolate the absolute value. Get the absolute value all by itself. Number 2, write 2 equations. I'll explain that later. Number 3, solve the 2 equations. Solve the 2 equations. You do not need to check for extraneous solutions in these types of problems, okay, because we're not multiplying or increasing either side by using a variable. We're not going to do that like we did in the last 2 types of problems. Now, can I show you something really quick? You can take notes on this or just watch, okay? I want to show you that problem, and I want to show you this problem. If I gave you this equation here and I asked you to solve it, right away you should see that one answer is 5. Because if I put a 5 in for x right here, and this x is gone, what's the absolute value of 5? Well, the absolute value of 5 is 5, so you would get out 5 equals 5. And so this is a good answer. It checks. You should see that right away. But do you notice another answer would also work? What else could I put in for x here that would give me out a true statement? Could I not put a negative 5 in? Could I not also say that x equals a negative 5? Sure I could. What's the absolute value of negative 5? 5. and I get out 5 equals 5. Do you see that okay? And so what I'm trying to show you here is this. Absolute value equations quite often will have how many answers? 2. I want you to see that. You need to understand that. A typical absolute value equation will usually have 2 answers. Okay? Alright, so I wanted to make sure you see that okay. If you'll look at it again just one more time, when you look at this original equation right here, you should be able to see right away that if you put a 5 in for x, you would get out a true statement, or if you put a negative 5 in for x, you would get out a true statement. So we have 2 answers to that equation. Now let me show you something else that you need to see. Look at this equation to the right. Sometimes absolute value equations will have what? Yep, you guessed it, no solution. Can you think of any number that you would put in for x in which you would get out a negative 5? No way, it's impossible, guys, because absolute values mean to make the number positive. That's what these lines mean right here. Okay, so if I were to put a 5 in for x, I would get out a 5, and 5 does not equal negative 5. If I were to put a negative 5 in for x, I would get out a positive 5, and 5 does not equal negative 5. So sometimes there will be no solutions. And do you see when that would happen? Isn't it obvious? Whenever your absolute value is equal to a negative number, there's no way you're going to have a solution because you'll never get out a negative number. So I wanted to throw those thoughts at you real quick before we get into this. Okay, let's solve these 4 equations. Are you ready? All right, step 1 says isolate the absolute value. Let's start with this equation right here. All right, let's stack these up over here and get us some room. All right, okay, here we go. Now, step 1 says isolate the absolute value. Well, the absolute value is already isolated, is it not? It's totally all by itself on one side of the equation. So step 2 says write 2 equations. That's what you don't know how to do, and I'm going to teach you right now. So contain your excitement. Here we go. First of all, you just get rid of the absolute values and you just write the equation like it is. X equals 5. Isn't that easy? And then you write the exact same equation again, the exact same equation, only you change the sign of this number over here. So now I'm going to write x equals, and right here I had a positive 5, so we're going to put a negative 5. Let me go over that one more time. I'm not sure I'm explaining that very well. When I tell you to write 2 equations, you write the equation just like it is without the absolute value, so x equals 5. And then you write this equation again, only you change the sign of this number over here. And then step 3 says solve the 2 equations. Well, they're already solved. There's nothing you can do. They're totally solved. So you can write your answer like this, or you could write your answer like this. Either way is acceptable. There we go. That's really not too difficult, okay? Let's apply these 3 steps again to this next problem here. All right, here we go. Okay. Step 1 says isolate the absolute value. Well, the absolute value is already isolated. It's all by itself over here on the left side of the equal sign. Step 2 says write 2 equations. So what I've taught you to do is you write the equation just like it is without these 2 bars. So x minus 3 equals 2. Then I've taught you to write this equation again, only you change the sign of this number right here that I'm circling over and over and over. All right, and so what I would have is x minus 3 equals a negative 2. Now, I'm amazed at how many students, when I teach them, change these signs over here too. And I've never said to do that. I have never said to do that. You change the sign of this number right here. Okay? So you write the equation just like it is without these 2 bars. And then you write this equation right here, over here, only you change the sign of this number right here. And that's what you do every time. It's really pretty simple. So now step 3 says solve your 2 equations, bring your 3 over and make it a positive 3. So one answer would be 5. And then bring this 3 over and make it a positive 3. And your answer would be 1. Now we do not have to check for extraneous solutions. However, if you put these two numbers in, you would see you get out two true statements. Put a 5 here. 5 minus 3 is 2, and the absolute value of 2 is 2. Now put in a 1 right here, a 1. 1 minus 3 is negative 2, and the absolute value of negative 2 is 2. 2 equals 2. So there are your two answers. You don't have to check them. I just did that so you would understand your answers do work. So pretty cool. I've saved the easiest ones for last. These are not too bad, okay? Okay, let's try this equation here. Please take some really, really good notes, all right? Step 1 says isolate the absolute value. Don't forget there's a negative sign here in front of the absolute value. Be careful, okay? And don't forget this is a positive 9. So if I'm going to get the absolute value all by itself, I first got to bring the 9 over and make it a negative 9. So now this is gone, and you're left with, don't forget your negative sign, you're left with negative absolute value of x minus 2 equals a negative 2. Now please don't miss this next step. Really having this negative sign here means there's really a negative 1 right here. Okay, so the absolute value is really not all by itself yet because there's a negative 1 right here. So I've got to divide this side by a negative 1 and divide this side by a negative 1. If you do that correctly, these cancel out, and now you're left with the absolute value of x minus 2 equals 2, because a positive 2 divided by a negative 2 divided by a negative 1 is a positive 2. Does everybody see what I've done there? I brought the 9 over and made it a negative 9, and then divided both sides by a negative 1, and now the absolute value is totally isolated. It's all by itself. Hopefully you see that okay. So step 1 is done. I have isolated the absolute value, okay? Now what I've taught you to do next is you're going to look at step 2 here, write two equations. So remember what to do. You first of all write the equation just like it is without the absolute values there. And then you take this equation right here and you write it again, only you change the sign of this number right here. So instead of putting a positive 2, I'm going to put a negative 2. And now let's see what happens. Here we go. Bring your negative 2 over and make it a positive 2. So x equals 4. And then bring your negative 2 over and make it a positive 2. And x equals 0. Now you don't need to check these, but it's always wise to. So I'm going to put a 4 right here. 4 minus 2 is 2. The absolute value of 2 is 2. 9 minus 2 is 7. So it works perfectly. And now we're going to put a 0 in. Put a 0 right here. Well, 0 minus 2 is negative 2. The absolute value of negative 2 is 2. And 9 minus 2 is 7. It totally works, okay? So these are your two answers, okay? And again, you don't have to check them, but it is wise sometimes to do that. Last problem on the whole video, guys, so way to be troopers, way to hang in there, and let's solve this and we're done. Okay, step 1 says isolate the absolute value. Well, if you'll notice, the absolute value is not isolated. There's a negative 2 right here that I would really like to get rid of. So it's multiplying, so the opposite of multiply is divide. So I'm going to divide this side by a negative 2 and this side by a negative 2. Now these cancel, and I'm left with the absolute value of 3x plus 2 equals negative 4. Now you know what you're doing right now? You're like, okay, I'm ready. On to step 2. Write two equations. Hold it. Hold everything. I gave this problem to you for a reason. Do you remember way back at the very start of this part of the video, I showed you that when you have the absolute value of x equaling a negative 5, how you would get out no solution, because you can never have an absolute value equal to a negative number? Well, that's what you have here. You have an absolute value equal to a negative number. There is no solution to this. Please listen to me, Matthew, Caleb. Anytime you have an absolute value equal to a negative number, you're not going to get out a solution. The answer is no solution. Okay? Now you know what a lot of students do? They do this. So let me pause. Sorry, let me pause and put some closure. So your answer would be no solution. Go ahead and write that down. Now, you know what some students do, and this is so wrong. They'll look at an equation like this, -2. Let's say the original problem looked like this. They'll see that the original problem looks like this. I just made this up. And they'll say, oh, I've got a negative number over here. So the answer is no solution. No, no, no. Always do step one first. Always do step one first. Isolate the absolute value, because sometimes after you're done isolating the absolute value, the right side will have a positive number, like this situation here, and then you can go ahead and solve it. So always isolate the absolute value, and then after you've isolated the absolute value, if you then notice that you have a negative number right here, an absolute value equal to a negative number, then you know right away the answer is no solution. Okay? All right, now that I've thoroughly put you to sleep for the past hour, remember you have no homework at all, so you can enjoy the rest of the day off when it comes to math. You will have homework tomorrow. Don't hesitate to call or email if you have any questions at all. And this is difficult math, so you're going to have to work hard to learn it, but you can do that. And tomorrow I will give you a pretty good assignment to help you practice these problems over and over, okay? Have a good day. Call or email if you have any questions.